Hello everyone. Thank you for attending today's Watershed webinar, Stormwater Pollution, Our Streams and What We Can Do. Our presenter is Mr. James Eckenrode, Engineering Lab Manager at St. Francis University.
Michael. As Michael said, my name is Jim Eckenrode, and I am the lab manager for the engineering department at St. Francis University. I was also previously a watershed specialist for 18 years at a local county conservation district. So let's just get started. And then, of course, if we have questions along the way, please feel free, as Michael said, to place those in the chat. I don't love presenting this way. I prefer to do it in person, but this will work for us. So just give us a little bit of a leadway on trying to get to all the questions. Okay, thank you. Okay, so today we're going to talk about stormwater. I need to make one more thing. Okay, today we're going to talk about stormwater pollution, our streams, and what we can do. Again, my name is Jim Eckenrode from St. Francis University, and the engineering department is located in the School of STEAM. There are two types of pollution: point source and non-point source pollution. Point source is the easy one. It's an exact location where the water enters the streams, for example, a pipe. And we've done a really great job since the mid to late 70s in addressing point source pollution. Non-point source pollution is basically a point source origin that is widespread and that's not easily to be monitored or regulated. And some examples are agricultural runoff, parking lot runoff, and mine discharges. And we'll get to more of those. Let's talk about non-point source pollution. The non-point source pollution basically occurs when rainfall, snowmelt, irrigation, whatever, water running across the land has the opportunity to pick up pollutants and then deposit those pollutants into our local lakes, rivers, streams, whatever, in addition to our groundwater. So again, some examples: non-point source pollution can come from agriculture, forestry, septic systems, urban runoff, including your streets, your homes, your lawns, construction sites. And it also includes physical changes to stream channels and habitat degradation. Non-point source pollution remains the nation's largest source of water quality problems. Let's talk more specifically about Pennsylvania. The top three sources of water pollution in Pennsylvania are agricultural runoff, abandoned mine runoff, and stormwater runoff. And to that point, we have 5,765 approximately miles of streams in Pennsylvania that are impacted by ag runoff. And you can see the other numbers: almost 5,600 for abandoned mine runoff and over 3,200 from stormwater. So here's an example of AMD, or abandoned mine drainage. Kind of a classic looking stream, depending on where you live in the state of Pennsylvania. But this stream is obviously impacted by something. In this case, it's metals, usually iron, aluminum, or manganese. And
Hey,
the
Jim.
orange, yes?
Was this where you said to launch the poll?
Yeah, that'd be fine.
Okay, so sorry to interrupt. Here's a poll question.
No problem.
We'll take a second with this. Hopefully you can see it. So everybody take a second to vote.
I'll take a break too.
And give it another second here. All right, so I'm gonna end polling in 5, 4, 3, 2, 1. And hopefully you can see the results there. We've got non-point source pollution at 64% and point source pollution at 36%. So whenever you'd like to address that, Jim, feel free and continue, and I'll be quiet.
Sure, no, I appreciate the commercials. It gives me a second to take a drink. So the answer is non-point source pollution. That's correct. It is not point source pollution. As I mentioned, we've gotten really good over the last 40 years, 50 years in addressing point source pollution because it's easy to find. It comes right out of a pipe and it's easy to regulate. So our number one source of water quality problems in Pennsylvania today is non-point source pollution because of the fact that the pollution is spread out over a large area and often hard to manage. Okay, so we've talked about point and non-point source pollution. Let's talk about some types of non-point source pollution. First one I have on my list here is abandoned mine drainage. So again, stream, this is a local stream, central Pennsylvania. It is impaired by metals. That's the orange tinge that you see in the stream. So the metals usually in streams that we find from abandoned mine drainage are iron, aluminum, and manganese. Iron being orange, aluminum being white precipitate, and manganese being usually in black in color. In addition to that, connectivity or the salts in this stream are very high, over 1,000, and pH in this stream on this day when I took this photograph is about a 4.3. So pH is definitely acidic. Okay, so next on our tour of non-point source pollution is sedimentation. Photograph on your left, you can see a tributary coming in, and you can see as it mixes with the main channel there, it's bringing in some sediment into the stream during a rain event. And then on the right, a little even more obvious photograph is water running off the construction site. And of course, that water is running directly into the storm drain there at the bottom of your screen. As I mentioned, non-point source pollution does include ecosystem destruction. So in this case, we have a highly eroded bank. There's no vegetation there. So there's nothing to hold that bank together. There's nothing to reduce those velocities when there's a large storm event. And then all that material, all that sediment gets deposited in the stream, which you can kind of see in the bottom of that photograph where the water, like at the center of the stream, it looks very sandy or very silty. Another example of non-point source pollution is agricultural runoff. Start with the photo on your right. So our fields are often covered in all of our crops, be it vegetables or our grasses, hay, straw, whatever we're making, different grasses, alfalfa, stuff like that. But there's a lot of times throughout the year where Pennsylvania farm fields are not covered with any vegetation, and that would allow for erosion. Photograph on your left, not dissimilar, but in this case, we're focusing on the fact that animals and their manure have direct access to the stream, and you can see in this case that the bank has no protection on it. It's slumping down, sediment is easily to get in the stream, and it's definitely a problem. So stormwater contributes non-point source pollution to our streams and waterways, right? Stormwater is the water that is basically shed from any impervious surface. So again, stormwater runoff specifically is when heavy rains that fall on your streets, the parking lots, sports fields, gravel lots, or rooftops basically reach our streams, which I had mentioned earlier. That water then rushes into nearby storm drains, which we saw in the photograph with the sediment, and then that's carried to our local stream. And I'm sure that everybody on this call has a pretty good idea of where that water goes, but I do want to make this point because often when I give the presentation to the general public, some people skip over this. At one point in time in our history, we called storm drains storm sewers. And it gave people the misconception that any water that was going down that storm drain was then being sent to a wastewater treatment plant or to a sewer plant. That is obviously absolutely not the case. At one point in time in history, maybe 70 years ago, that was the case. But since then, most of our sewage and our stormwater has been separated. So basically anything that you see go down those drains, those storm drains, is basically getting piped to the closest stream. So if you see trash, oil, paints, any runoff from residential areas, any kind of chemicals, anything you see go into those storm drains, it's basically going straight to the closest stream. So it's always a good point to remember. Here's a photograph of an impervious surface parking lot, and you can see the water is starting to build up and run off the parking lot. And in this case, it's already carrying a little bit of sediment with it. So a good example of stormwater. So stormwater is not only a problem for surface water, it also contaminates our drinking water or our groundwater, which in many areas we use for drinking. Stormwater can have high concentrations of toxic chemicals in it that are going to affect our health, both children and adults, and our local community. And the reason I've separated children and adults because there are certain chemicals that do travel in the water that can affect younger children more than adults, depending on their development. And additionally, excessive stormwater causes accelerated erosion, which we've seen. So groundwater, I haven't spoken too much about groundwater, but there is that connection, and I want to make sure that it's clear because groundwater is twofold. One, all these chemicals, all these processes that we see, so the city environment, agricultural fields, agricultural animals, discharges from pipes, runoff from housing areas, they all very quickly impact our surface water. So the runoff goes right into our streams. But all those impacts are also slowly working their way through our soils into our groundwater aquifers. And then depending on their proximity to those aquifers and the stream, you know, that could take months, years, or even decades for those pollutants to then travel to the stream. Because remember that our streams are flowing not only during rainy days, but also during sunny days, even for long, extended periods of time. And those streams are recharged by the groundwater. So there's that direct connection between groundwater and surface water. As I mentioned, stormwater runoff has detrimental effects to our streams. And that could be a water quality issue, as well as a water quantity issue. So both the pollutants themselves, and then of course, in this case, the effects of stormwater, or I'm sorry, effects of flooding, which are both quality and quantity issues. Let's take a second and look at a water balance. So on your left side of your screen, we have pre-development. And in case some of those labels aren't clear, first we have the water falling down to the surface, and that's being intercepted by our canopy. So that means less impact. So each one of those drops is hitting a leaf or a tree branch or some vegetation before it hits the ground. So it's not displacing that soil when it hits the ground. And then we have evapotranspiration. So because our trees are living and breathing, they're taking up and giving off some of the water. And in this balance, the key to the diagram or the figure here is look at the size of the arrows. So then we work our way to the bottom of the pre-development water balance, and we look at surface runoff, we look at interflow and base flow. The surface runoff arrow is the smallest arrow in pre-development. A lot of that water is getting infiltrated into the ground, into our interflow, and some of it is making it into our groundwater supply, into our base flow. On the flip side of that, we look at the post-development. Transpiration is a much smaller component. Also because there's less trees. There is very little, if no, canopy interception. This surface runoff is very large. Interflow and base flow arrows are both very small. So instead of that water going into the ground and recharging our aquifers and our well systems, it's running off, it's picking up all the sources of pollution, and it's going directly into the stream. And unfortunately, it's going usually in high quantities, which equal high velocities, which are causing excess erosion. So let's talk about a local neighborhood. So let's call this this is another central PA town. It's just a single image. We'll call this suburban. It's not exactly city, but it's not exactly rural. And we can see our road structure and our roof structure. Let's take one house. Let's say it's a ranch style house. It's 35 to 60 feet, 35 feet wide, 60 feet long, about 2,100 square feet. So we have a 1-inch rainstorm over 1 square foot of that house. We're going to generate 0.6 gallons of water. Now, we don't often have 1-inch rainstorms, although we did have one last week. I think it was about 0.95 inches when it was done. But let's say we have 1/2-inch rainstorms and 1/4-inch rainstorms. And then we take that 2,100 square foot rooftops area, we multiply that by 0.6 gallons, we're going to get 1,260 gallons of water per 1-inch rainfall. So even if we say it's a 1/2-inch rainfall and we have 630 gallons, or a 1/4 inch and we have half of that, we're still talking about several hundred gallons per roof area, and a 1/4 inch, 1/2 inch, or 1-inch rainstorm. So does that produce a lot of runoff? Well, we take everyone's houses, all of our rooftops, all of our garages. Then we throw in all of our sidewalks and streets, and here we are. Okay, so we're not there yet, but I love to throw in this slide. But this isn't unlike an urban environment, unlike a city, where all of the surfaces are impervious. There's very little opportunity for infiltration, and the water is running off. Okay, so what can we do to help? So I have 2 options here. We're going to actually talk about 3 options today. We're going to talk about rain barrels, rain gardens, and riparian buffers. And there's just little cartoon drawings of both, and we'll get a little more in depth into each one. All right, so what is a rain barrel? A rain barrel is a rainwater collection system which stores roof runoff water to be used for other activities. It could be used for washing your car, cleaning your windows, or watering your lawn, and most likely used for watering your garden or your flower beds. Some of the personal benefits are saves money on your water and sewer bill, so you're not using your water. You're not using your treated water, your domestic water. And usually your domestic water use is tied directly to your sewer bill. They just assume that water that you take in will go back out. So you don't have to pay sewer at all, and you're not paying water. It's reducing runoff because you're capturing that water for a short period of time during the rain event, but you're capturing it to be used. And I always say, instead of being money saved for a rainy day, you're saving water for a sunny day. And then you can also use it to reduce the need for treated water unnecessarily. It's a little bit of a pet peeve of mine, although I do it just like everybody else. We treat water to drinking water standards for consumption and for cooking and for cleaning. And then when we go wash our car with it, we water our lawn with it, or we spray down our windows or whatever we're doing outside. And in my opinion, it's just a poor use of treated water, which is made for drinking, to do all these outside activities. I understand that we need to do them, or we like to do some of them, and I do some of them myself, but if we can limit it, that would be much better. So let's just talk a little bit about the design of a rain barrel. So first you tie your rain barrel to your downspout, and so you need a way for the water to get in the barrel. And then some key components to the rain barrel are your inlet, your overflow, because this barrel will, on most storm events, be filled and actually overflow. So again, say if we were down to the, 320 gallons or something in a 1/4 inch rainstorm, and we separated that by, and you have a rain barrel at all 4 corners of your house, or at least you have downspouts at all 4 corners of your house. So we split that and say it's 85 gallons. Well, a rain barrel at 50 gallons is going to be full in 1/4 inch rainstorm. So just take that into consideration when you think about how you're going to use your rain barrel and where you might want to place your rain barrel. But again, so we have our inlet, so we need an overflow, because again, that rain barrel is going to get filled up. We need a spigot to get the water out. And in the one design on your right, there's a drain. I've never installed a drain on my rain barrels because usually I put my spigot so low that I get 3/4 of the water out. And if I ever need to move the rain barrel, I just push it over, let the rest of the water drain out, and then just pick it up and move it. At the end of my presentation, I'll bring this design back up if anybody has any specific questions. I've built hundreds of these, and I can tell you what products I use, which ones I like better than others. But they always contain the same components: an inlet, an overflow, and a spigot. Okay, thanks.
Is now an okay time to do the poll?
Yeah, sure, great.
All right, so we got another poll here. Has anybody tried to build their own rain barrel? Excellent. So I'll end the polling here in a couple of seconds. It looks like we're about 31% yes and 69% no. So I think there's a new activity for some people to try here.
Absolutely.
Thank you.
They are a lot of fun. Thank you, Michael. Okay, I'll see if I can get control back. Okay, great. So let's move on to this next slide. Let's move on to rain gardens. Rain gardens serve a similar purpose, but a rain garden is a shallow, low elevation depression that utilizes a combination of plants and soil, in this case, to aid mitigation of rainfall and reduce runoff. Same principle, we're temporarily holding this rainwater to be used for something else. In this case, we're growing our plants or any vegetation that we have in our rain garden. And the goal is, again, to take that water out of the system, out of that rainfall event, so we reduce our velocities in the stream, and we also limit the exposure that water has to pollution. And I want to make it clear here, and I probably will through the presentation later, rain gardens are not ponds. They do not hold water. Your rain garden should not have standing water on it for more than a 24-hour period. If it does, then you probably need to look at your design for your rain garden. So just a point to remember. Again, what are the benefits of a rain garden like rain barrels? Gardens are aesthetically pleasing. They can increase your property value because they do look nice. If you belong, or if you live in a municipality that charges stormwater infrastructure fees, those fees are usually directly related to your impervious surface. Whenever you take out whatever area you had in your lawn to put in your rain garden, then you're removing that impervious surface. Therefore, you wouldn't be charged for that area that you've reduced your impervious surface by. So, and although not as popular in central to western PA, absolutely something that's happening in eastern PA and the whole way up and down the East Coast. So again, stormwater infrastructure fees could be reduced. You're going to improve the local water quality, and you could reduce your building's heating and cooling costs from shade and vegetation, as opposed to maybe just a lawn next to your house. Healthy yard benefits. So I've got a bunch of benefits for rain gardens. So for your yard, habitat biodiversity. We talked about that water balance. We're talking about storing that water, giving it the opportunity to infiltrate and to reach our groundwater supply. Your rain garden can assist in nutrient balance if there would be an upstream or uphill source of nutrients, whether you're fertilizing your lawn or there's nutrients coming from your garden or something. It could be captured and used by the plants in your rain garden. You're going to reduce chemical usage just because you don't need to use chemicals in your rain garden as opposed to a lawn. You're going to have improved water quality. Here's an image that I really like for rain gardens, and I'll just talk about it briefly. Again, like the rain barrel, I'll bring these up at the end. We can talk about them if anybody would have any questions. But in general, it's preference to always have your rain garden downstream of your house, downslope of your house, which makes it easy because water runs downhill. So if you're going to get water to your rain garden, that's the best way to do it. Of course, you always have the option to pump or whatever if you want to collect water and take it up your rain garden. But it's always good to have your rain garden at least 10 feet away from your structure. The general rule for water coming out of your rain barrel is 3 to 4 feet from your structure, downhill sloping. Rain gardens are 10 feet because you want to make sure that that water that's infiltrating isn't making it into your foundation. Once you take those into consideration, you basically over excavate about 3.5 foot hole, put in a foot of stone, then your construction fabric, and then your soil mixture. And if you see on the right hand of the screen, there is a prepared soil mixture. It's a great application in helping you get that prepared. It's basically 50 to 60% sand, 20 to 30% compost, and 20 to 30% topsoil. So that's your growing medium. And then you plant your plants. And then of course, just like any flower garden or whatever, you would top with mulch. And then I always want that to be at least 4 or 6 inches below your current ground level around your garden. So it does look like a depression when it's done. So again, it will hold that water temporarily up to 24 hours. Give that water an opportunity to move down through the soil, hit the stone, and then easily access the groundwater. So again, I'll bring that up at the end if anybody has any questions. Some examples of local or native water-loving plants. For trees, I have arrowwood, witch hazel, smooth alder, silky willow, and ninebark. And then for grasses, or for plants, I have switchgrass, coneflower, swamp milkweed, and cardinal flower. But there's a whole list that we'll get to at the end of the presentation. Okay, so rain gardens. Here's a rain garden that was installed, it says 2005, so a while ago. And this is probably one of the first ones that I've seen installed. This is year 1. So again, down sloping from the house. This case, it was new construction, so actually the pipe, the downspout is running right into the garden, into the middle of the garden. But it's underground, so they don't have to deal with a pipe across the surface. And they, built this, over-excavated, built this rain garden, finished it off with some plants and some compost on the top. So year 1, year 2, it's looking pretty nice. And year 3, quite grown. Some people might say overgrown, but I mean, I think that looks great. Obviously, this isn't the best picture that's probably taken in late fall, early spring, when the vegetation was not at its fullest or prettiest, but still, that's an area that they don't have to mow. It's great habitat, great diversity, as opposed to the monoculture of the grass, and I think it looks really good in the yard. Here's a good example. Now, this was from the Eastern Shore, or at least from East Coast, outside of Maryland. So these people have a really nice rain garden in their yard, and then the municipality came through and actually put a curb cut to reduce the water running across the roadway, and actually enters right into the rain garden. So great application there. And this is a rain garden photo that I took from Sheets parking lot. Sheets is implementing rain gardens in most of their projects. So if you look around the outside of the pads or the parking lot areas at Sheets stores, convenience stores, you'll see local rain gardens. Okay, finally, I would like to talk about riparian buffers. And of course, a riparian buffer is just a buffer along a stream. So let's talk about riparian buffers. So in the center of the photograph, you see we have the stream bottom. And then working your way out from the stream bottom, you have zones 1, 2, 3. And then in this case, they have examples for cropland and pasture. Zones 1 should not be disturbed, and it's usually undisturbed forest. Zone 2 are managed forest. Zone 3 is you're working your way out, runoff control. And then in zone 4 would just be our normal day lives, whether that's light industrial, residential, agricultural, whatever. What are the benefits of buffers? So clean water and air, and that's probably the most important. So these buffers act as natural filters to protect our streams and our water resources. So they can filter out nutrients, sediment, chemical pollutants such as fertilizers or herbicides, manure, as I said, nutrients, and any other possible chemicals. Forested buffers can improve air quality by releasing oxygen and changing chemical pollutants into carbon compounds used for food. They act as a sponge, not unlike wetlands, although buffers aren't as efficient as wetlands are, but still they act like a sponge to absorb large flow events. So during flooding events, that's why the best application of, water or land right next to the stream is a park or something, because forested buffers and wetlands are really great at absorbing that flow and that energy from large storm events. They act as a natural screen between the natural and urban environments, and they can protect viewscapes and aesthetics. Benefits are great for protecting, buffers are great for protecting banks and bank stabilization. And so if you have a diverse riparian area, as opposed to just a monoculture of grass, you have deep-rooted plants that firmly anchor the shoreline into soil. This protects the bank from erosive powers and flowing water. They act as shock absorbers, again, diffusing the energy that's hitting the stream bank and running across the surface. And they can protect property and reduce the impacts of flooding, as I mentioned. They also slow down runoff before it reaches the stream, and thus reducing erosion, because those bank areas are, they do need protected, and they can be easily eroded because they're so close to moving water all the time. And they also provide critical habitat for wildlife, such as aquatic insects, fish, and animals. So more on wildlife. Buffers provide food, shelter, travel corridors, and breeding spaces. And honestly, all of those are equally important. As we have more spread and we take over more areas and remove more forest land, those travel corridors become very important. Those breeding spaces, those resting spaces for animals as they travel. Shelter, obviously, and food, all just as important. Our insects spend a substantial portion of their life cycle in upland environments. They provide shade to the stream, which reduces thermal pollution. And they provide habitat and food for macroinvertebrates, and those are those leaf packs that we see in the spring that those macroinvertebrates live on and provide their food source. And then again, they act as a buffer between sensitive bird species and potentially disruptive activities on adjacent lands. Again, you'll hear me say more than once that buffers really act as a way to protect our streams from our everyday lives. And they do a great job of it. So here is a buffer installed along a stream, a riparian buffer. And you can see, it looks like on the left side, that buffer is probably over 100 feet wide. So from the stream back. And on the right side, it looks like there's some trees already in there, some mature trees. So maybe that buffer is only 50 to 100 feet wide. If you haven't seen one of these photographs before, basically all those little white things that are sticking up are basically tree tubes to protect the trees from mostly deer browse and competition from the weeds as the plants start to take up root and start to grow. Same application. In this case, this buffer is a little more mature, less tree tubes, but in this case, it's up against an agricultural operation, so they put a fence in to keep the animals out. During the establishment phase of a buffer, you may need to do some mowing, some removal of native species, and you may need to do some herbicide applications to keep down that competition to remove invasives. But after that, you can just let it grow. Okay, so things to consider when developing a buffer. So a buffer width should be 25 feet or greater, which I'll get to in a second. If you do have a larger buffer width, it allows for a larger tree and shrub establishment. Again, we're going to limit any access to that area, be animals or mowing equipment or any other motorized vehicles. If you have questions about plant types, see DCNR's publication on native plants, which I'm going to show you at the end of the presentation. And again, preparation for the area may include removal of non-native species and the use of herbicides and mechanical removal. So a lawnmower. So what with? So if you have the room, again, riparian buffers really are for people who live in more rural environments, but sometimes even in suburban areas, you have the opportunity. So if you're just looking at stabilizing the stream bank and the aquatic food source, you can do it between 25 and 50 feet. If you're looking at that canopy protection, that thermal protection for water temperature moderation, could be anywhere from 25 to 150. You want to look at nutrient removal, it's more like 35 to 125 feet. And you work your way up, sediment control, say 40 feet to 150. Flood control, 75 to 200. And of course, wildlife habitat is going to start at 35 feet, but the more you can give the wildlife, the more they'll accept and take. And in this case, the chart goes up to 300. So it gives you an idea. And then this would be for all three zones. So this would include a zone 1, a zone 2, and a zone 3. And these are the benefits you're going to see from studies that have been done in addressing either a pollutant issue or a quantity issue or providing habitat. So I said I would show you this graph, and this is just a graph of native plant species in Pennsylvania. And you don't really need to know which types and everything, but what I want to bring your attention to is that little red box on the far left side. That's grass. Rooting depth of sod is about 4 inches. And that 4 inches is not going to hold a stream bank together that has no protection, so either has no cover, no trees, no deep-rooted plants. It's just not going to be able to hold it. So that's why you often see slumping banks or banks falling in where you have your normal residential bluegrass or common grass. So just take that into consideration when you're thinking about what plants to plant along your stream bank and how 4 inches isn't going to hold much together. Okay, so what can you do if you don't live next to a stream? Well, you can still have gardens, whether it's a rain garden or a buffer or just a small area. You can plant those gardens. Great opportunity for removing impervious surface. And people say, well, grass is not an impervious surface. I've seen studies that a manicured lawn that's mowed every weekend in the summer for 50 years, from houses that were built in the 70s or 60s, that their runoff coefficient, so that the amount of water that runs off a lawn isn't much different than concrete. It's a little hard to believe, but it really is fact. Lawns really aren't a great vegetative type to cover your lawn with, or I guess mowed grass is not the best type if you want to think about infiltration, reducing runoff, and improving water quality. So if you have space and you like flowers, you can plant flower beds. And again, these are great for pollinator gardens, whether it's for the bees or the butterflies or other insects, some great opportunities. As I just mentioned, a native garden equals a great pollinator garden. The best thing about gardens is, in addition to it improving water quality, reducing runoff, it takes very little management. Once you've established these gardens, you do not need to use fertilizers or pesticides. And from time to time, you may need to use some mowing or herbicides to control invasives. But they really do take care of themselves once established. They are a little tricky to get established. And again, there's a multitude of benefits for planting gardens in your yard. Okay, so I have questions. And I will give everybody a chance. I want to stop sharing for a second. I want to show everybody a couple resources that I just love to use when I am doing these types of projects. Michael, can you see pretty rain barrels?
Yes.
Okay, great. So if you want to have a rain barrel in your yard, it does not need to look ugly. I just wanted to show you that you can paint your rain barrel to look like anything you want. You can use it to match your house, or you can make it look like RTD2, or you can have some of the most beautiful pictures you've ever seen on a rain barrel. And I saw a great one today. They made it look like a Campbell soup can. So it may not be your cup of tea, but pretty cool. I also wanted to show you that there are a number, too many to count, of resources for designing your own rain garden. And these are just great because they often cover the design of the garden, the size of the garden, the design. So here on your right, you're looking at the screen. You know, each one of these circles represents a plant. So they're going to have taller plants in the center, shorter plants out towards the edge. You're going to have multiple colors. The resources are really endless. So feel free to look for those. They cover depths, they cover different plant species, different flower species. They just cover everything. If you're looking for native plants in Pennsylvania, I highly recommend you check out this website. And I'm just going to copy it now. And I'm going to stop sharing for 1 second. I'm going to throw it in the chat so that everybody can see it. I have a couple of these actually I want to share, but this one is a great resource from DCNR. And it contains the next two resources I'm going to share. So I won't go over their website, but I want to show you two of the resources that I use. This is my favorite DCNR resource. If you are new to gardening and planting, and you want to prioritize native plants, grab this resource. It covers sunny moist, sunny dry, obviously shady and shady moist and shady dry. This resource covers common name, scientific name or Latin name. It tells you when they bloom, what color they bloom, how tall that species might get, and then some notes about them. And it covers trees, shrubs, and perennials. Great resource to get started. There's always that flower that somebody has that you've never seen before. Probably not going to be found in this common guide, this short guide, but a great place to start for people who want to use native species and are interested in maybe mixing colors and matching colors and having certain colors bloom certain times of the year. Great resource. And one more, finally, if you have a larger property, there's this Pennsylvania Bureau of Forestry planting and seedling guide, and it covers seeding plots for large areas like acres. It includes application of herbicides and preparation of the seed bed. It includes, you work your way down through the list. It includes a little guide on what to do, what month of the year. So what year are you planting? What year are you herbiciding? What year are you mowing, if there's mowing? And then it also covers all the native species. In this case, here you can see a list of warm season grasses and cool season grasses. It covers the seeding mix. And I can show you that right now. Let's see if I can get to that. Let's see. So here, if you're looking at, this, so there's right-of-way areas with slopes less than 15%. These are native and non-native seeding mixes. So you're going to plant a bunch of seed and then broadcast that seed or drill that seed into the ground. You're going to have like big blue stem, little blue stem, Indian grass, switchgrass. So again, these are areas that are not going to be maintained, which is really nice. Although some of them do take a little bit of maintenance. I planted 2.5 acres of warm season grasses on my property. And about every 5 or 6 years, I'm supposed to mow it. just so that I can maintain the grasses so that woody vegetation doesn't move in and it just doesn't evolve over time. And then you get through the grasses section. There's some great sections towards the end about how to plant trees. These are live stake trees. I didn't show you a picture of live stakes, but those are trees. They're like stakes, but it covers all shrubs, all pine trees, all hardwoods. It covers their wildlife value. And I think it's just a great resource. And I'm going to stop talking because I could talk about all these resources for a long time. Really interested in it. But if anybody has any questions, we can handle that however Michael would like to. I think the easiest way to do that would be we can start some of these chats, and then we can also, if anybody has any questions, just feel free to unmute yourself and ask.
That sounds great. So I don't know if you're able to see the chat there. Do you want me to read the question to you, or do you want to read it yourself?
Okay, so the first one is, do I have a resource for a safe barrel to use for vegetable gardening and watering? There are two main resources for barrels. They do change by distributors, so a lot of garden stores will have sources for rain barrels. There are production ones that you'll pay more for, and they're just generic ones that have been used for food sources. I know that Surplus City in Altoona has always carried Del Grosso barrels, and Del Grosso's barrels either have in them vinegar or vodka or something in their food manufacturing. So you just rinse those out and you can use them. I also know that closer to Pittsburgh, there are a couple entities, a couple of the Italian food distribution companies have barrels that were from olives. So you just need to look for a food grade barrel. And they're not that hard, just ask around. Those are two examples of sites that I've used to get barrels from the past. And I did have one barrel, the olive oil barrels, it takes a little while to get the oil out, but it really isn't going to hurt your plants. So it takes a bunch of washes to get that out. But otherwise, it works really well. As far as step-by-step instructions for the rain barrel, okay. I did say I was going to show those pictures again. And I think all I have for questions anyway, so let me go back. I do not have, to answer your question quickly, no, I do not have instructions. There are many different kinds, they're available all over the website. Several of these sources came from Montgomery County, Maryland, and their landscapes project. Those are pretty nice. I can go through the rain barrel really quick. At a hardware store, you can buy these grates. They're made for stormwater in your lawn. The company's called NDS. It's an 8-inch grate. I take that 8-inch grate and I put a screen over the inside of it, and I use that and I band that together with a hose clamp. That keeps the mosquitoes out. For the overflow, I just use a sump pump hose kit. It comes with all the fittings. So you cut a hole in the barrel and you just use the pieces from that sump pump hose kit, which is something you buy off the shelf. And it comes with like 20 feet of line of hose. So that's my overflow. And my spigot, I use a 3/4 inch brass hose bib, a little bit more expensive than plastic, but I like the brass because it actually cuts the barrel as I'm kind of like screwing it into the, I'm sorry, yeah, the brass cuts the barrel as I screw it into the barrel, as I screw it in, and it basically seals it. So I don't have to use any kind of putty or caulking or anything like that. And it works really great. From the photographs here, the only thing I would do is I put my spigot I usually put my rain barrel on bricks or blocks, and I would put my spigot much closer to the bottom, but still so I could get a bucket underneath it. The only thing I can say is make sure whatever you put your rain barrel on, that it's secure and solid. You can see in the photograph to the right, to the left, it says gravel footing. If you think about 50 gallons, 7.8, let's just round it to 8 pounds per gallon. You're talking about a 400-pound barrel when it's full of water. Think about that before you have an emergency. So you don't want it to either fall over, hurt somebody, or then decide you have to move it when it's full of water. So just take that into consideration. Same resources with rain gardens. You know, feel free to look around. If you ever have any questions, the basic design's always the same. And a lot of them I've seen now don't have stone. I like that stone because it's great for storing water temporarily. It gives you more capacity. But I really like that mix of sand, compost, and topsoil. It's great for your plants anyways, but it's really, it has large pore spaces, allows the water to run right through and get into the groundwater. Does anybody have any other questions? So what I recommend for a high school, I like the rain barrel projects because I think they're a lot of fun. As far as rain gardens go, you obviously need to develop something with your physical plant or your maintenance department. There are equations, I can't remember the numbers, but you can take your, arguably you could just take your total roof area, divide that by the number of downspouts, get an idea of how much water you'd be talking about. I gave you an idea of how much water you might produce. And then there are equations where you take that information and you put in roughly the size of a rain garden you would need as far as space. And then I definitely recommend making your rain garden some oblong or weird shape. It makes it a lot nicer. If it's a perfectly round circle or a square, it doesn't look like a garden, it doesn't look very nice. Yeah, but there's no reason why students couldn't do that. You're going to need some equipment, probably some excavating. Like I said, most rain gardens, you over excavate 3 feet down. You need to make sure there's no utilities in there and no limiting layer, like either a high water table or bedrock. But yeah, then you can build it back up and plant. And it's a great way to introduce students to native plant species too. Because if they go to big box stores and look at trees and plants that are available, most of those are not native. So if you want to teach your students about native species, build something with them, either raised beds or gardens or rain gardens or whatever. Okay, so there's a question about stream banks, large trees coming down. Okay, so that's a loaded question, but thank you, Joy, for the question. So, ultimately, we'd like to reduce water reaching the stream quickly. That's why we have rain gardens. That's why we have rain barrels. So we're trying to reduce runoff, reduce those velocities. So then we're reducing the erosion that's causing those banks to fail and the trees to fall in. The next thing we would do is try to stabilize those banks. You can stabilize them with stone, with trees. You can revegetate them. You can plant them. And as far as the trees that are falling down legally, as long as you don't have equipment in the stream, you're allowed to remove them. So you can get in there with a chainsaw, you can get in there with a truck or a cable or whatever. You're allowed to remove those trees. That's perfectly legal. And as long as you don't have equipment in the stream, it's fine. But to work backwards, the best way to solve that problem would be to address the source issue. Does anybody else have any questions?
If not, I'm going to ask one.
Yeah, sure, Michael.
So thinking of schools, I'm thinking, there could be a lot of rainwater coming off of the roof up there, a lot of water to kind of dissipate into the ground. Is there such a thing as too big of a rain garden? Like, is there an average size of one? I mean, I know we saw some pictures of pretty small ones. Like would you kind of have a buffer between them or anything? Or can they just be acres on, I mean, I guess at that point it's a field, but is there kind of a size that you would recommend?
It's always easier to start small when you're doing something for the first time, but really it's going to be based on how much water you're generating. And I guess to that point, you don't need to. So almost all the equations look at how much water is coming down that spout and then sizing that rain garden appropriately. But you can still, like rain barrels, you can say, okay, we only have so much area to work in. We're going to address 25% of the water coming down that downspout. And then you can have just a way for the excess water to go around it. I mean, that's pretty common. That's just like that overflow in the rain barrel. You can have an overflow in your rain garden and say you can only have enough area to address 25%, 40%, 10%, whatever it is. I would never miss the opportunity not to try. But no, there's no limit. Again, it's not supposed to hold water, so you don't have to worry about a pond. There should be no health and safety issues. If it's balanced, there's not going to be. I've never had mosquito issues with a rain garden. Again, because there's no standing water. I can't remember if it's 7 or 14 days now, but there's a life cycle to mosquitoes, so they need a certain number of days with standing water. You don't have that. You can have that in your rain barrel, and that's why I put the screen on the inside of that inlet structure to keep the mosquitoes out. But no, I wouldn't say that there's a good place, I know, a certain size to start with or whatever. It's whatever works for your site. Okay. If anybody would ever have any questions, I am not an expert, but I'd be glad to point you to some great resources. I would be glad to answer any of your questions on rain barrels or rain gardens or riparian buffers. I've done riparian buffer plantings. I've done 5 acres of my own property of tree plantings. I've tried lots of different things. I can give you an idea what works well with students. We've done a bunch of planting projects with students. I will tell you one side note that I didn't bring up in the rain garden is people have some concerns about what might be getting, like what's running off your roof into that rain barrel. There are concerns about, if you have metal roofing and galvanized roofing, are those chemicals getting into your rain barrel? What about the tar and from shingles, stuff like that? So the short version of that story is none of those are a real problem if you always water the base of your plants, not put it on the flowering part or the vegetable. And if you are going to do that, then you just have to wait about 7 days before you can eat the vegetable. Your biggest source really of problem is going to be your birds and your squirrels and that, and them going to the restroom on your roof. But again, as long as you water the base of your plants, well, plants really doesn't matter, but for vegetables, if you're going to eat it, just make sure you wait 7 days or water the base and not the actual flower that you eat. Okay. Michael, do you have anything else?
I just want to make sure that everybody sees in the chat, I have placed the Act 48 form, so please provide feedback. Even if you don't want credit, we'd love to hear your comments about today's session. But I really want to thank our presenter for today's expertise on the stormwater management and everything you provided. I think it's been valuable. So thank you very much. And if anybody has questions about this or future sessions, let us know, and we hope to see you in a couple of weeks. So thanks so much for joining.
Thank you.